In number 8, we have a special right triangle that's a 45, 45, 90 triangle. And the reason that's important is because it tells us two things. It tells us that these two are the same, which means this is an isosceles triangle, and therefore the legs must also be the same. So those two sides are the same. And it tells us a specific equation that we can use that compares two sides of the triangle. So we're going to do both of those things as we solve for A and B in this case. B is going to be the easiest thing to solve for, and I've already marked what it's congruent to. We know that B has to be 3 because we've stated that this side is one of the legs of an isosceles triangle, and it's congruent to this side. Well, since this one's 3, B also has to be 3. We don't really even need to do any work. Okay, the trickier part is going to be finding A. Now, here's where we have to use that equation that only works for a 45, 45, 90 degree triangle. Okay, that equation tells us that the hypotenuse of a triangle like this is going to be the same length as one of the legs, except for it's going to be multiplied by the square root of 2. This equation is true, but it's only true in this type of triangle, so don't try to use it in other places. Okay, once we've got that, it's just a matter of filling in what we know. The hypotenuse is this one across from the right angle, and it's listed as A, so that's what we're gonna substitute in for hypotenuse. We've already determined that the legs are both 3, so we're plugging that in there, and we're going to multiply that by the square root of 2. Now, if I can simplify this any more, I would simplify this any more, but 3 times the square root of 2 is as simplified as it gets, and so that's as far as I'm going. Okay, this hypotenuse has a distance of 3 times the square root of 2. If you wanted to get a rounded value, you could plug 3 times the square root of 2 into your calculator, and you get like roughly 4.5 or so, but that's not as exact as leaving it in this radical form.